Good day, students, and welcome to the June 2012 New York Regents exam Mathematics B Part 1 video series. I'm going to be going over the first 10 questions. And before we start, I just want to commend you for taking the time to go over this video so that it shows that you care about your performance on these exams, and hopefully you can learn something from these problems. All right, so let's go ahead and start off with question number one. Um, In question one, it says Pete and Sean decide to raise money for charity by having a carnival in their backyard. In one of the games that they set up, the probability that a person will win is zero point 0.4. If Robin plays the game 9 times, what is the probability that she wins exactly 4 times? All right, so in this um, probability problem, there's going to be a selection process, right? We have out of nine times, we're going to choose 4 wins. All right. So 4 wins out of 9 times are going to be we're going to choose 4 wins, and then obviously if they're exactly 4 wins, they're going to be 5 losses, right? So since we care about just the winnings, how many ways can we choose 4 wins out of a total of five tries? All right, is that going to be combination or permutation? Since we're just choosing, there's no order involved, it's going to be a combination situation. So we're going to be choosing 4 out of 9. So the way you write it is the bigger number comes first, 9. And since we're choosing wins, we're going to have C4. So this is the number of ways you can choose 4 out of 9. All right. Um, so now we're going to do the other part of the binomial theorem by using uh, wins and losses. All right, so how many what's the probability of winning is 0 0.4, right? And how many times does she want to win? Exactly 4 times. So we're going to multiply this by the probability of winning, which is 0 0.4, times the number of times she wants that, which is 4. So 0 0.4 to the fourth power. And then the losses, since she wins 4 times, how many times is she going to lose? 5, right? So it's going to be something to the fifth power, all right? We know probabilities always add up to 1. So if the probability of winning is 0.4, 40%, what's the probability of losing? You just simply subtract 0.4 from 1, and that gives you the probability of of losing, which is 0.6. All right, so here we're going to have 0.6 to the fifth power. So this is basically how you break it up. And you can clearly see that the answer to number 1 is option 3. All right, let's move on to question number 2. It says which number is the largest? So what I'm going to do is I'm going to simplify them as much as I can, and it will make it easy for me to order them. All right, so first thing I'm going to do, let's do the first one. Number 1, we have 1/4 raised to the -1. If you have a negative exponent, all you just need to do is reciprocate. The denominator goes to the top, and the numerator comes to the bottom. So this is simply 4/1 raised to the first power, and your final answer is 4. Okay, number 2, option 2, we have 1/4 raised to the 0th power. You know that the number raised to 0 is always unity. It's just 1. All right, number 3, 1/4 raised to the 1/2 power. If you're raising uh, a number to 1/2, is basically, this is the power, the top is the power, and this is the root. Okay, so since we're raising this to the first power, it doesn't really count, but we're going to be bringing 1/4 to the second root. Okay, so let me just write that remark real quick so you get what I'm saying. This is the power, and this is the root. Okay, so applying that to this problem, we're going to be taking uh, the 1/4. We're going to have 1/4 to the second root, raise the whole thing raised to the first power. Okay, but since we're raising something to the first power, it doesn't do anything. It doesn't change it because it's just going to be one copy, which is just itself. So this is going to simply be the square root of 1/4. All right, applying the properties of radicals, this simply becomes the square root of the numerator divided by the square root of the denominator. All right, square root of 1 is 1, square root of 4 is 2. 1/2 is equal to 0.5. All right, we can see that this is still the biggest one thus far. Now, last option, option 4, we have 1 over 4. I can't even see it anymore. 1 over 4 raised to the second power, and that is, uh, we're just going to distribute this power to the numerator. Oh, we're going to distribute the power to the numerator, to the 1, and then we're going to distribute it to the 4 on the bottom. All right, so it's going to be 1 square over 4 square. So it's going to simply be 1 over 16. Okay? And if you do 1 over 16 in your calculator, if you don't know how to convert, you just enter 1 over 16 in your calculator and you get 0.0625. So this is 0.0625. So we can clearly see that the biggest one out of all of them, the largest is 4. Okay? So your answer is option 1. All right, moving along to question 3. It says the point A, which is 6, 3, maps onto point A prime, which is 2, 1 under a dilation with respect to the origin. What is the constant of dilation? The constant of dilation is basically what an integer that you, or a number, sorry, a number that you multiply by certain points to move it to another point, okay? So let's say I want to dilate x, y. So if I want to, in 2D space, if I want to dilate x, y, I just multiply by this d, d of x, y, and that's going to be basically become d times x times d times y, and then this we can just call x prime, y prime. Okay? So d is basically my dilation. D is my dilation constant. Dilation constant. You can call it dilation constant or constant of dilation. In simple terms, it's the number you multiply each coordinate by to get your image. Okay? So the question is, what am I multiplying 6, 3 by to get 2, 1? Okay? So I know that d times my x will give me my x prime under the dilation, and and d times my y, whatever the constant is, will give me y prime under the dilation. So d for both coordinates are always going to be the same. So if I multiply d times x to get my x prime, what is d going to be? How do I find the value of d, which is my constant of dilation? All I simply do is divide the corresponding coordinates, right? So if I divide this by x and divide that by x, this first inequality tells me that my constant of dilation d is simply the image of x over the original x right there. Okay? Or if I wanted to use the y coordinates, which is exactly the same thing, I'll divide both sides by y. Divide this by y, divide this by y, because I'm looking for d, my constant of dilation. D is simply y prime over y. Okay? So all this is saying that if I wanted to find my constant of dilation, I can just take this and divide it by that, and that gives me the answer. Or I can take this and divide it by that, and that'll give me my answer. Okay? So what on earth am I saying? Let me write it out so that you can understand. Um, the point xy, the point, ooh, wrong color. Um, my point xy is basically, my point xy is 6, 3. And then my image, x prime, y prime, under dilation is, what is it? It's 2, 1. Okay, so if I wanted to find d using this formula, I'll just go x prime, which is 2, divided by x, which is 6. If I reduce this by dividing by 3, dividing by 2. If I do this by dividing by 2, which is basically you're reducing fractions, you're going to have 1 over, divide this by 2, top and bottom, you're going to have 1 over 3. So there goes your constant of dilation using x. If I wanted to use y, which is redundant, but it doesn't matter which one you use, I just go y prime, which is 1, divided by y, which is 3, and that's it. So basically, our constant of dilation d is 1/3. So you just pick one coordinate of the image and the original, and then just divide it, and that gives you your d. All right. So my answer for number uh, 3 is option. So your answer is basically option 1. Okay. All right. Moving along. Question 4 says if cosine theta is negative 4/5 and theta lies in quadrant 2, what is the value of tan theta? So this is a problem where we just have to draw the angle, the angle in the right quadrant, and also draw the use this points right here to determine what my components of the right triangle are, and then I can find tan theta from there. All right. So this is a SOHCAHTOA type problem. Um, let's go ahead and draw out our right triangle first, and then we'll go on after that. So we have a coordinate system like this, and we're in quadrant 2. We know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. All right, this is my x coordinate, and that's my y coordinate. All right, so we're going to draw a right triangle in quadrant 2, and then I'm going to apply the measures. All right, so you just draw your right triangle like this. You remember your reference angle always starts from the x-axis, all right? Your reference axis is the x-axis, so you always have to draw your triangles on the x-axis. All right? So if you were in quadrant 1, it will look something like this. If you're in quadrant 3, it will look something like this. If you were in quadrant 4, it will look something like that. That's what your triangles will look like. And then your angles, these are your reference angles. I know you already know this, but just a real quick review. So your reference angle in quadrant 2 is right there, reference angle in quadrant 3, right there, quadrant 1, and then quadrant 4. Okay? So just keep that in mind. It's important to draw the triangle correctly so you can get your measures accurate. All right, so we're doing quadrant 2, so this is the triangle that we have, all right? And then this is theta. All right, so now we have, if this is theta, hmm, what do I know? I know that the side opposite the angle is called opposite, opposite, okay? This is 90 degrees. The longest side is always the hypotenuse, and then the other side is the adjacent, right? Okay, so now uh, we know SOHCAHTOA, right? Opposite of a hypotenuse, adjacent of a hypotenuse, opposite of adjacent. I know that cosine theta is negative 4/5. So using CA, what does CA tell me? CA tells me that cosine of an angle is the adjacent over the hypotenuse. All right? Ooh. All right, so cosine is 4/5. So I know the hypotenuse doesn't have a sign because it's a radius, so this has to be negative 4. So my adjacent is negative 4 right here. So this is negative 4. If I measure it back, this will be negative 4. Okay? So this, my adjacent is going to be negative 4, and my hypotenuse is the radius is going to be 5. All right? So let's keep that in mind. So hypotenuse is 5. This whole length right here is 5. And this length right here is negative 4. The question asked us for tan theta. So in TOA, what does TOA, what on earth does TOA mean? I know ka means adjacent of a hypotenuse. TOA, tan theta is what? Opposite over adjacent. Okay, so tan theta is simply going to be my opposite over my adjacent. All right, I already know my adjacent is negative 4. What on earth is my opposite? Oh, we have to find it, okay? So since we have a right triangle, we're going to use the Pythagorean theorem to find the missing side, all right? So we're going to use a squared plus b squared equals c squared. These are the legs, the adjacent and the opposite, and this is the hypotenuse. So another variation of the Pythagorean theorem using O, H, and A is a squared plus O squared equals H squared. It doesn't matter which you call adjacent and the opposite because they're both the legs, okay? Just remember the hypotenuse is always C. So this equation, a derivation of the Pythagorean theorem, will help me figure out what O is. All right, so I know A is negative 4 square plus O square, and H is 5 square. Okay, and I simplify that, I'm going to have 16 plus O square equals 25. Subtract 16 from both sides. I'll have O square equals 9. Divide both sides by, take the square root of both sides and you have your opposite equals 3. Okay? So there goes your opposite. Your opposite is 3. Okay? So since the opposite is 3, and mind you, the adjacent is negative 4, that tells me that tan theta for our opposite of adjacent is 3 over negative 4. Okay? You can just write it tan theta equals negative 3 over 4. It doesn't matter what you put the minus. Okay? So there you have the answer. So your final result is for number 4 is option 3. Okay. All right. Now let's move on to number 5. So for number 5, it says Tracy, a political campaign organizer, realizes that the number of hours needed to get out a mail-in for her candidate is inversely proportional to the number of campaign hours workers she has. If she uses information in the accompanying graph, how many hours would it take to do the mailing if 125 students were used? So, this is an inverse variation problem, all right? So, let's declare our variables. Let h equals number of hours, okay? And then w equals number of workers. All right. So there are two things there, direct variation and inverse variation. If you have an inverse variation, if you have inverse variation, um, so basically says um, says hours needed is inversely proportional to campaign workers. So basically H varies inversely. This is a relationship. This is a variation. This is the symbol for variation. So H varies inversely with workers, so it's going to be 1 over W. Okay? So this is the relationship for inverse variations. If we introduce a constant of variation, then we can make this an equality. So let's call K our constant of variation. So that's going to make me conclude that H equals K, let me put that over there, equals K over W. Okay? And this is my, this K that I just introduced. Sorry about that. This K I just introduced, K is the constant of variation. Constant of variation. In this case, inverse variation. Okay? So what on earth does this tell me? This equation, what does it tell me? It tells me that if I multiply both sides by W, like that, it tells me that H times W is always going to be constant. Whenever I have a inverse variation, the two quantities that exhibit inverse variation, whenever you multiply them together, guess what? You always get the same number. All right, so this is the whole idea of inverse variation. Okay, so this is basically the formula that we're going to use to solve the problem. All right, so in this problem we have a situation here. We're looking for how many hours. So we have the coordinates. Okay, let me take that off. We have the coordinates. We have the coordinates 50W. 50, 40. All right, 50 is my x coordinate, so this is W, and 40 is my y coordinate, which is h. Okay, so this is x and this is y. You know how you graph. You know how you do your graphs, right? This is x and y. All right, so can I use these two quantities to find my constant of inverse variation, my constant of variation? Absolutely. See this equation right here? It tells me h times w is always going to be constant regardless, all right? So I know that 40, which is the value of h, times 50 is always going to be constant regardless of anywhere you are at on this graph. Okay? So if I multiply them together, my constant of inverse variation is going to be 2000. All right? So this tells me that if I pick another point and I know one of the components, I can always find the other one. All right? So this question says, wait a minute. What if the number of hours, what if the number of workers is 125? How many hours would it take? So so now the problem is if W equals 125, find H. But wait, we know that if we multiply them together, we will always get 2000, right? So let me consult my equation of inverse variation. Again, I know that HW is always equal to K. In this case, I know that W is 125, and I don't know H, so I'm going to have H times 125. So if I multiply these two, they're always going to be equal to what? The constant of inverse variation, which is 2000. Any point you pick, the other one multiplied by that coordinates will always give you 2000. All right, so to get H by itself here, just divide both sides by what? By 125. All right, so divide this by 125 and divide that by 125, and then you're going to have H equals 16. All right. All right. So let's see what is the let's see what is the answer. What is the answer to this? Answer is option 2. All right. Answer option 2. All right. Let's move on to the next question. Question 6. It says, what is tan x over secant x expressed in simplest form? Now, they're the mom and pops of all trig functions, the two trig functions that all the other trig functions came from, and they are sine. This is the mom, and cosine. This is a pop. Okay? So whenever I'm simplifying trig functions, I always express my trig functions as these two. I have a whole bunch of videos on trig identities, so you can go to my site to mathgoodserve.com to view them. Those really help you to understand what on earth I'm doing right here. All right, so these are the mom and pops of all trig functions because I know that if I wanted to create tan, for example, I just simply go sine over cosine. If I wanted to create cosecant, for example, I'll just reciprocate sine. If I wanted to create secant, for example, I'll just reciprocate cosine. And if I wanted to create cotangent, I'll just go cosine over sine. All right, you see how you can create the other four trig functions using these two? These are the mom and pops, okay? So keep that in mind. So let's go back to the problem. Tan x over secant x. Now, if I express these two using the parent trig function sine and cosine, it's much easier for me to simplify it, okay? So, what is tan? Using your trig identities, I know tan is sine over cosine, so tan is going to be sine x over cosine x. Why? Because tan is sine over cosine, all right? Divided by, what is secant? Secant is the reciprocal of cosine. Be careful. Secant is not the reciprocal of sines. Many people do this. I don't know why. Secant equals 1 over sine. This is wrong. No. It's S goes to C, C goes to S, all right? So secant is the reciprocal of cosine, so this is 1 over cosine x, okay? Now, whenever you have a fraction in the denominator, all you do is you drop the numerator, sine x, and you multiply it by the reciprocal of the denominator. So if I reciprocate this, I just flip it bottom to top, top to bottom, times cosine x over 1. All right? So notice what happens. This cosine and this cosine cancels out, and your final answer is sine x. Yeah. All right? So that tells me number 6, our answer is 4. All right, let's move on to question number 7. It says, what is the value of the discrete sum from 0 to 3 of 3CR? All right. So the sigma basically means we're adding terms from 0 to 3, which are 4 terms. So let's write it out. So we have this discrete sum from r equals 0 to 3 of 3CR. How do we do this? Let's see. We're going to start from 0, and since it's discrete, we're going to go 0, 1, 2, 3. Where we're going to be plugging them in, we're going to be plugging them into the variable, which is r. See, r starts from 0 and goes all the way to 3. So r is going to assume these 4 values, and then we're going to compute the combination, all right? So this equals 3, choose 0 for the first substitution, plus when I plug in 0. When I plug in 1, I'm going to have 3, choose 1, plus when I plug in the next one, 3, choose 2. And when I plug in the last one, 3, choose 3. If I add all this, if I work all these out and add them up, then that'll be the answer, right? But guess what? There's a trick to this. Remember C, another way for generating C is by using the Pascal's triangle. So this is the third row of Pascal's triangle, all right? So what is Pascal's triangle? Starting from row 0, you have 1. Oh, where's my pen? All right, you have 1. And then row 1, 1, 1. Row 2, 1, 2, 1. Row 3, 1, 3, 3, 1. Guess what? If I work this out, I'm going to get these numbers right here. So this is basically 1 plus 3 plus 3 plus 1. Okay? You can do this in your calculator and verify. You see that this is exactly what you get. So using the shortcut of Pascal's triangle, I got this. So I'm going to work this out. 1 plus 3 plus 3 plus 3 is 2 plus 6, which is 8. Okay? And your answer is 1. If you don't remember a Pascal's triangle, just plug this in your calculator and it will work out perfectly for you. All right, let's move on to question number 8. It says, what is the exact value of arc sine? What is the exact value of cosine of arc sine 1 over half? Whenever you're dealing with 1/2, or if you're dealing with 1/2, or root 3 over 2, um, functions like this, these ones are derived from the special triangle. Okay, so the special triangle that I'm talking about is the 30, 60, 90 triangle. Let me sketch it for you real quick, and then you see where if I'm getting my answers from. So this one is good to have it memorized, so I could just do this from memory without even thinking about it because I have my triangles mastered. So in your 30, 60, 90 triangle, you have a special relationship. So this is 30 because it's the smallest, this is 90, and this is 60. You always have the shortest side is always 1, and the longest side is 2. And then when you do Pythagorean theorem, this is root 3. Okay? This is one of the special triangles. The other special triangle is a root 1, is a 1, 1, root 2 triangle, the 45, 45, 90, but that doesn't apply here. So which of these angles will opposite of a hypotenuse give me 1/2? From so, ka, toa. All right? Which, since arc sine is 1/2, sine of what would give me 1/2? If I pick 60, this would be my opposite, and this would be my hypotenuse. So basically, this triangle tells me that sine 60 is root 3 over 2. Is that what I want? No. How about sine 30? What is sine 30? Sine 30 is if I use this one, this would be my opposite over my hypotenuse, which is 2. If sine 30 is 1/2, that tells me that if I take the inverse sine of both sides, the inverse sine, let me call it arc sine. Inverse sine and arc sine are the same thing. If I take the arc sine of both sides, arc sine of 1/2, we can see this cancels out. It tells me that 30 degrees is actually the arc sine of 1/2. So in this problem we have right here, cosine of the arc sine of 1/2. Since sine of 30 is 1/2, the arc sine of 1/2 is 30 degrees. So this problem can now reduce into cosine, and instead of arc sine of 1/2, it's going to be arc sine of 30 degrees. Okay, so now what is cosine of 30 degrees? Look at ka. What does ka tell you? Adjacent of a hypotenuse of this triangle we just created. So ka of 30 degrees is going to be, wait, this is my opposite. I'm going to get confused. Because we're dealing with 30 degrees, this is my adjacent. Okay, and this is my hypotenuse. So cosine of 30 degrees is adjacent over hypotenuse, which is root 3 over 2. Okay, so there you have it. This one is also easy. You can just plug this directly into your graphing calculator, and it will give you the answer. But you just need to know the decimal conversions of these numbers. Okay, so there you have it. Um, so you just need to know that root 3 over 2 is approximately 0.866. You need to know that 1/2 is 0.5. And let's see, the square root of 3. And the square root of 3 is, what is the square root of 3? Square root of 3 is 1.73732. And root 2 over 2 is approximately 0.707. So if you have these decimal figures in mind, you can derive this in your calculator. Okay, I'm not doing anything fancy here. If you know these things right here, when you're doing this problem, oh boy, I just read the whole thing. When you're doing this problem, all you just do is you just plug this into the calculator, okay? Exactly as it is. Well, the way you plug it into the calculator is you go cosine of sine to the -1 of 1/2. You plug it in like that, and then it basically gives you what the answer is. All right, let's move on to the next question. Question 9. It says if 7 to the x equals 3, then x is equal to what? So let's do this one. So for this one, we have 7 to the x equals 3. Now remember, the opposite of exponent is logarithm, right? So if I want to cancel this exponent right here, I'm going to take the logarithm of both sides. So I'm going to take log base what? Since you have 7 here and I want that canceled out, I'm going to pick log base 7 of both sides. Okay, log base 7 of 7 to the x equals, on the right side, log base 7 of 3. Okay, remember there's a logarithmic rule. It says log base n of n to the x is equal to x, because these two cancel out. That's what I created here, because I know that log base 7 of 7 to the x, these two are inverses, so they're gonna cancel out. So watch this. This and this cancel out. Boom. Isn't that cool? So you're gonna have x equals log base 7 of 3. Oh wow, we don't have anything here. So I'm going to use another logarithmic rule. So it's cool to know your logarithmic properties to do problems like this. This is known as a change of base formula. Okay, so it just tells you that log base b of a is equal to whatever the number is, it goes to the top divided by the log of the base. Okay, log b. All right. This is known as a change of base formula. All right, this is base 10. If there are a particular target base, you just put it here, top and bottom. It doesn't matter. All right, so for this case, I'm going to apply the change of base formula here. So you're going to have log. Remember, the number goes to the top. The number goes to the top. And the base goes to the bottom. Log base 7. See the base right here? That goes to the bottom. All right, so let's see. Do we have an answer? Yes, we do. The answer to number 9 is option 3. Okay? All right. Let's move on to the last question in this series. Option 10. It says roots of the equation are rational and unequal, rational and equal, irrational and unequal, or imaginary. So to do this, we're just going to focus on one part of the quadratic equation, which is known as a discriminant. Your quadratic equation is x equals -b plus or minus the square root of b squared minus 4ac over 2a. All right, certain things to note. This is what tells me if you're going to have a double root or two distinct imaginary roots or two distinct rational or irrational roots, okay? So this is known as a discriminant, this piece right here. So we're going to focus our energy on the square root of b squared minus 4ac. Now, if this is equal to 0, we're going to have two rational and equal roots. All right. If this were negative, let's freeze here. I don't need to carry the square root because, yeah. Okay. If this were negative, less than 0, That basically means that you're going to have an imaginary number because you're taking the square root of a negative number, so it's going to be um, imaginary. Okay? Imaginary. Okay? If b squared minus 4ac is greater than 0, it's going to be um, it's going to be rational, and it could be rational equal. I mean, it's going to be rational or irrational, but they're going to be unequal for sure. Okay? So whenever if the discriminant is bigger than 0, it's either going to be rational or irrational, but you guaranteed one thing is going to be unequal. All right? Whenever it's equal to 0, it's going to be rational and equal. Okay? So the question is, when is it rational? When is it irrational? If this is a perfect square, it's going to be rational. If it's not a perfect square, then it's going to be irrational. So basically, b squared minus 4ac is greater than 0 and a perfect square, like 9 and all that cool stuff. Then you have two rational. You know what rational is, right? Like it can be expressed as a fraction, no square roots and stuff. So if this were bigger than 0 and a perfect square, then to be rational and unequal. All right. If it were not a perfect square, we'll have a situation like this root 3. What is that? That is irrational. So if it's we're not a perfect square but greater than 0, then um it will be irrational and unequal. All right? So those are the things you want to keep in mind. So let's if all these things I'm saying here are too complicated for you, you just work the problem out and you see what on earth the answer is. All right? So I'm going to focus my energy on the discriminant, that piece, and then whatever I have there will tell me what the answer is. All right? So in this problem, 2x squared plus 5x minus 6. I just need to correctly state my A, B, and C, right? So A is 2, B is 5, C is negative 6. All right, so looking at my discriminant, I'm going to look at B squared minus 4AC. I'm going to look at the sign first. If it's negative, I know it's imaginary. If it's 0, I know it's a double root. If it's positive, I know it's going to be real, either rational or irrational. So let's do this. All right, this is called the discriminant, FYI. Okay, discriminant. It helps you classify roots without even working out the whole problem. All right, so if I work this out, I'm going to have 5 squared minus 4 times 2 times negative 6. What on earth am I going to get here? Let's work it out. 25 plus 4 times 2 is 8 times 6 is 48. And that comes out to, oh, yeah, what is this? 73. Okay, 73. Okay, 73 is bigger than 0. Yay, that means we're not going to have an imaginary situation. But since it's not 0, that means it cannot be a double root. It cannot be equal. So for this case, we know that it cannot be imaginary since it's greater than 0. It cannot be equal because equality happens only when the discriminant is equal to 0. So it's either rational and unequal or irrational and unequal. So the question is this a perfect square? What happens when I take the square root of 73? Can I take the square root of 73? No. This number is irrational. Okay? So I already know that they are unequal. I just need to determine rationality or lack thereof. So since this is not a perfect square, guess what? My roots are going to be irrational and unequal. Okay? Remember, anytime it's bigger than 0, it's always going to be unequal. You just have to determine is it rational or not. So since this is not a perfect square, it's irrational and unequal. So your answer to number 10 is option 3. All right? So thanks so much for paying attention to this presentation. Please subscribe to my videos for future updates, and feel free to request videos. You can just email it to me and I'll try my best to help you out. Collection of clips can be found at mattgoodserve.com. If you like this video, you can click like down here. If you don't like it, just send me an email or post a comment, and I'll be glad to address whatever concerns you have. Thanks again, and have a wonderful day.